Add a copy constructor to the edge class. Did we talk about deep copy?
No.
Okay, well, there was definitely a lecture. I have video proof of it in which I did an example of a deep copy. But you're right that we certainly haven't done it enough because in assignment 6, you need to do a lot of deep copy and we've got to go spend some time on that. So I feel justified in asking one question on it, but yeah, we haven't done it enough for assignment 6. Okay. If we really haven't covered it at all, then this was an unfair question, but I think we have. If you think we haven't, then maybe confront me on this, but I claim I covered it a little bit. Let's show how to make an edge deep. Let's go up here to this edge class. What does a copy constructor look like? It has to have the same name as the class because it's a constructor. It has to have an edge because it's something to copy. What shall we call it? Copy me? I like that name. It makes it pretty darn explicit. Okay. Here's an example of a shallow copy. A equals copy me.a. B equals copy me.b. This is a shallow copy. Shallow copy is not deep copy, and so if you did this, you kind of missed the point of the question. The point of a deep copy is to make a deep copy, so we should have said A equals new vertex copy me.a, and B equals new vertex copy me.b. Now, if you made a new edge, then we've got an infinite recursion issue because these don't even have edges, and these are vertices, not edges. So this was the right answer. If you did this or something like unto it, I tried to be generous in finding reasons and excuses to give points, but if it was clear you didn't know what you were doing, that's what a test is. I was supposed to take off points, and so I did. Yeah.
We also have written a copy constructor in the vertex class and called that.
Oh yeah, because I'm using a copy constructor, that assumes there must be one here. So you really should have also come over here and done a vertex copy me. My keyboard not working today. And it's definitely the keyboard's fault, not my fingers. X equals copy me.x. Y equals copy me.y. Now, wait a minute, you say. Isn't this a shallow copy? Isn't this exactly what I told you not to do in the edge class? What do you have to say about that?
X and Y are primitive types.
Yep, and that is the great insight of deep copy. Whoa, that's more than I meant. Zoom into, I just want to see them both. Okay, the edge copy constructor has to make a new vertex. Why? Because these vertexes are class objects. The vertex class, I feel like I just said vertex. The ints are primitive types, therefore, if you copy them, you're copying them by value. So when you make a deep copy, you have to copy by value, not by reference. And here we are copying by value because they're primitive types. Here we're copying by value because we called new. That's really the only thing there is to teach about deep copy. When you have a class object, you have to copy it, not just the reference. When you have a primitive type, well, that's all there is, so you just copy it, and it is by value. Does that make sense? Okay, I've now covered deep copy again. I will cover it yet again because we have a whole assignment on it, but that's all there is to deep copy. You just need to make a constructor and copy everything deeply, not shallowly. Okay. In Java, when a primitive type is passed as a parameter, that one, its value is copied on the stack. Any questions? Okay, no problem.
You need to ask that twice?
Did I ask it twice?
Yeah.
I certainly did not.
No.
Really? Did I ask it twice? That's hilarious.
They're very similar, yeah.
Okay, well, you know, when you make a test, you get kind of closed-minded, and that happened. Oh, now I screwed up this thing. Here, let's start a new page. I want to undo it. I just want to come down right here and say, insert page break. That almost looks right. That looks right on. Okay. Nope, not quite. There we go. Are we on 9 already? It's 8. Yep, we're on 9. Consider the game represented in the diagram above. Okay, by the way, most of you did all right on this question. And that kind of surprised me because a lot of people really had trouble with this whole concept in your coding. But I had to admit, this is basically geometry class type stuff, right? And you all had to pass calculus to get into this one, so this shouldn't have caused problems for you. And most of you did very well, so I guess it was me being silly to even ask this question. But, well, let's do it. Here's the game. Given expression for the length of A. Basically, we got to figure out how long that is. It's going to be the model width, this big long arrow here, minus this whole thing and that whole thing, right? Basically, in fact, how about I screenshot this so I can clipboard, open this thing, paste. Okay, I think you'll agree with me that if we want to get this width, we want to know this length, but all we know is this whole darn length. We basically need to subtract out this portion and this portion. And so this big long one minus the two short ones will be this one, right? It's kind of visually obvious. Well, that's expressed as follows. That would be model.width minus, and then I made parentheses here because I'm going to say view.x plus view.width. And there you go. If you forgot your parentheses, that was a little mistake. If you did minus on this one and didn't have parentheses, then you were technically correct, and that's right. Anything that was right, I accepted. If you somehow thought that Luigi or the pipe had something to do with it, well, you're wrong, because there's no way to utilize Luigi or the pipe in computing the length of A. It kind of looks like it, because it looks like they line up against each other, doesn't it? Well, they don't. If you look at these numbers in this next one, you'll see that this thing is not drawn to scale, and if you actually do draw it to scale, it's kind of funny. I had my daughter take this test, and she got out a piece of graph paper, and she drew it to scale according to these numbers. And basically, Mario is Luigi's way over here, and the pipe is way, way over there. And then she just showed it up to me, and she said, "Look, they're not even close to colliding. How can you ask this question?" And well, yeah, sorry. If you thought this was drawn to scale, then I deceived you. Okay, give an expression for B, this length. Well, it's basically the view's width minus what? Bunch of stuff we don't have. How are we going to do that? Oh, we have pipe X and the width of the pipe and the width of the whole model and A. So we could do that. Okay, how about model.width minus, what do we got? Minus A. Since we already calculated that, we can use it. If you had A depend on B and B depend on A, then it was impossible to calculate either of them. That wouldn't have been cool. But let's see, B minus pipe width and pipe X. Pipe.width minus pipe.x. Pretty sure that's a valid answer. There were probably lots of other good ways to do it. If your answer was right, you should have got full credit. If you didn't and your answer was right, please come argue for points.
Quick question.
Yes?
So do you need to calculate the B on the model, or can you, because it only goes from the pipe to the end of the view.
Yeah.
So could you have just done view width minus pipe width minus Luigi width minus Luigi X?
What does Luigi have to do with the position of the pipe? So it does kind of look like this, kind of looks like this edge lines up with that edge, but they don't quite visually line up, and they definitely don't line up in these numbers. So I'm thinking that was what got you. Let's see, if you knew Luigi's x and Luigi's width, and this edge was the same as that edge, and you knew the pipe's width, that would do it. I don't know, that's certainly a reasonable thing to argue, but I will say this corner isn't quite flush with that corner, so I don't know. If you think you deserve more than you got for that, bring it up and I'll consider it, because I see the point. Basically, if you take your expression here, oh no, we have to make an expression for this one. Well, that one was the answer. Here's how we know. You had to, in order to figure out does Luigi intersect with the pipe, you had to know Luigi's x position, and you had to use the view x position, right? Because we had to figure out where Luigi was in the model space, because the pipe is only known in the model space. Let me do it in my picture here. So I claim there's no other way to do it besides you have to know that plus that to see if it's greater than that. Right? There's really no other way to see if this edge is more than that edge. And so there's 4 terms there. And if we look at this one, well, that one and this one are the only ones with 4 terms. So you could have immediately ruled out the others. This one, it turns out, uses all the numbers that we just talked about. So that's the right answer.
The bottom one, we could use the bottom one if we're checking for collisions from the left-hand side of the model, of the Luigi model, as opposed to from the right-hand side, correct?
Let's see, 50 plus 33 and 267. So 50, that's Luigi's x, right? 33 is view.x, and 267 is what? Pipe x. Okay, so what we have to work with are, we have Luigi's x and pipe's x, and darn it, what was the third one? View's x. View's x. Given those 3 blue segments, can we tell if Luigi intersects the pipe? Depends how wide Luigi is. Oh, let's see. That would tell us if he intersects the right side of the pipe, if we also know the pipe's width. Yeah, so what we've got to work with here is the left side of Luigi and the left side of the pipe. So do they collide?
No.
I think you can't tell without the width of one of them. Yeah.
Because in the test,
That's true. So you can check from anywhere you want. You can check from this corner or that corner. I claim with just these 3 numbers, you can't tell if they intersect because none of them have any known width. If you guys think that I'm wrong, I'm happy to talk it through with you, and seems like you're making reasonable points, so if you know what you're talking about, that's worth something to me. I'm really not trying to nail anybody on technicalities. I'm trying to make sure we understand this stuff. So show me you understand it, and I'm happy. Oops. Okay, moving on. Suppose a class named Toyota extends a class named car. Which of these lines causes a compile error? The answer is that one. Here's why. Wait. Yeah, here's why that makes a compile error. Suppose you made a car. Is it a Toyota? I don't know. It might be a Honda, right? It might be a Ford. So saying Toyota T equals new car, well, it can't do that equal sign. And so it throws a, hey, these types don't match up. If you make a new Toyota, is that a car? Yep. Yeah. So the compiler says, cool, moves on. Okay. In Java, if you pass a variable of type int as a parameter to some function, it value on the stack is what happens with primitive types.